All right, we're going to be looking at the Unit 7 test review. So it looks like this right here. If you do not have a paper copy of this, you probably want to go to It's Learning and look at the plans for today, which is March 4th, and find Unit 7 review paper. Okay, so we're going to kind of walk through this, and I may not work every single problem because this would be the longest, most boring video known to man. So we're just going to look at a few key pieces here. So the first section is just vocabulary that you need to make sure you know for the test. So when we're looking at this, we can organize a triangle by sides, which is what 1, 2, and 3 look like. And then we can also organize a triangle by angles, which would be 4 through 7 here. Okay, so this would be naming by sides, and this would be naming by angles. Oops, there's an E in that word. Excuse me. Okay, so just kind of quickly going back through the vocabulary. If you have a triangle with no congruent sides, we call that a scalene triangle, so all 3 sides of the triangle have totally different measurements. If we have a triangle with at least 2 congruent, could be 3, but could be 2, we call that isosceles. So an isosceles triangle. I've lost an E in that word as well, sorry. And then a triangle with 3 congruent sides, we call that equilateral. Okay, so those are all the names based on side lengths. So now let's look at based on angles. So we have a triangle with 90 degrees. That's called a right triangle. If we have a triangle with one angle greater than 90 but less than 180, we call that obtuse. If it has 3 angles all less than 90, we call that acute, a little cutie triangle. And then a triangle with 3 equal angles, not 3 equal sides, all 3 angles are equal. We call that equiangular. So we can name a triangle by sides and by angles, so you can see 8 and 9 are examples of that. If I have a triangle, if I'm going to name by sides, right, then my options are scalene, isosceles, or equilateral. So either there are no congruent sides, there's 2 congruent sides, or there are 3 congruent sides. So you can see here, these 2 side lengths are both 40, but 32 is different. So if I'm going to name by sides, I would name it isosceles. I did it again. Cannot spell today. And then if I were going to name by angles, I would call it right, obtuse, acute, or equiangular. So if I look here, all 3 angles are less than 90, and so I would call this an isosceles acute triangle. All right, if I look at number 9 here, I'm going to name by sides. I got 40, 20, 35, all are different, so there are no congruent sides. So we're going to call that scalene. If I name by angles, these 2 are less than 90, but this one is exactly 90. So as soon as we see that 90-degree angle, we know this triangle is going to be a right triangle. Okay. If I want to create a congruent statement, I might just label a triangle, MAT, and CUP, so that I could make a comparison, right? So that tells me angle M is congruent to angle C. M is congruent to C, A is congruent to U, and T is congruent to P. So my angle congruences would look like this. Oh, wow. M is congruent to C. This should only be 1. Okay. So I could then make the tick marks for which sides are congruent. So between M and A, we go from 1 to 2. We go from 1 to 2. That's congruent to that. So MA is congruent to CU. And if we do TM, so 3 to 1, we look for 3 to 1. So that would be PC. And if I'm looking for the congruence of angle A, I can see this angle U. And I don't really need to mark the triangle, okay? Because if I look at the naming up here in the triangles, MA is going to be congruent to CU. That's always going to happen. It's always going to go in order. TM is going to be congruent to PC. And angle A is going to be congruent to angle U. So see how the corresponding parts match? Even in the naming of the triangle, the corresponding parts will match. All right, given triangle ABC, name a side. So there are 3 sides, AB, BC, and CA. Opposite vertex A. So here's vertex A. And if I want to name a side opposite that vertex, then I'm just going to go straight across from it, and I can see it's side BC. All right, if I want to name a side adjacent to vertex A, here's vertex A. Adjacent means next to, so it could be AB or it could be AC. Remember, adjacent means next to. If I want to name 2 sides and an included angle, I can do this 3 ways because I have 3 angles, okay? So if I did angle first, I would say angle A is between BA and AC. Angle B is between AB and BC. AB. No, it's not. Angle B. Yeah. AB and BC. I'm not crazy. Okay. And angle C is between BC and CA. Okay, number 14 says, if the measure of angle A is 63 and the measure of angle B is 47, then what's C? Okay. And we know that the sum of the measures of the angles of a triangle are 180 degrees if I add them all up. So I should be able to say 47 plus 63 plus angle C is equal to 180 degrees, and then solve for angle C. So if I combine these, that's 110. So 110 plus angle C is going to be 180 degrees. And if I subtract 110, then I'm going to get angle C is equal to 70 degrees. Then 15 says, what are the measures of all 3 angles if you are told it is equiangular? So basically what I'm looking for here is something plus something plus something has to be 180. And they all have to be the same. So I could sit here and say, okay, what if they're all 50? Well, 50 plus 50 plus 50 is 150, not 180. Okay, what if they're all 60? Well, 60 plus 60 plus 60 is 180. So you're looking for what can I add 3 times to get 180. Or just take 180 and divide it into 3, and that's going to give you 60, 60, and 60. All right, moving on. There are 2 main types of triangle problems that we work in terms of bringing algebra in. And it's what happens if we're looking at the sides and what happens if we're looking at the angles. Okay? So if we're looking at problem C here, there's really kind of 3 parts to this. The first question says, solve for x given AB is congruent to BC. And then the last part to the question is this triangle equilateral? Okay, so because I'm told that AB is congruent to BC, I'm going to mark that. So here's AB, and it's congruent to BC. So I know that AB is going to be the same length as BC. So if this length is 7, then this length also has to be 7. Okay? Which tells me that x minus 1, I'm going to get a pencil just in case I mess up. X minus 1 has to be 7. Right? Because the side is x minus 1, but it is also 7. And then if I just add 1, that will give me x. So x is 8. Now the second part of this says, is ABC equilateral? So equilateral means equal sides. So I need to find all 3 side lengths and decide if they are the same. Right? So I know what AB is. AB is 7. And BC is x minus 1. And x is 8. So 8 minus 1. So BC is also 7, which I kind of knew. And then I will need to do AC. AC is x minus 3. And x is 8. So that's going to be 8 minus 3, which is 5. So this is 7, and this is 7. So we know for sure it's isosceles. But this side was 5. So because the 3 sides aren't all the same exact length, we say this is not equilateral. All right. Number 17. Number 17 says find x and then find the length of each side. So we talk a lot about an isosceles triangle. We usually look at them like this. Right? So an isosceles triangle has 2 sides that are equal and 2 base angles that are equal. Okay, so maybe it will help you if we turn this guy on its side and you kind of see, oh, well, I've got 2 equal base angles. And if I have 2 equal base angles, then the sides have to also be the same length. So when we're working with sides of a triangle, we're always trying to find those 2 sides that are equal to each other so that I can make an equation out of them. Okay. So in this case, it's an isosceles, so these are the 2 sides that are equal. So 6x minus 4 is equal to 5x. Kind of struggled today in class solving for this because everybody wants to move the 5x. So I'm actually going to do that again here, but you can move the 6x over to the 5x and just divide by -1, okay? But it is everybody's natural inclination to move this smaller x over to try to keep x from being negative, which I've told you a million times I like to do. 6x minus 5x is just x, and I bring down the -4, and I bring down the equal sign. 5x minus 5x is 0, and that is perfectly okay. Then I just add 4 over, right? And that tells me that x is equal to 4. All right, so I've done the find the x part, and then it wants me to find each side of the triangle. So I'll start with BC. I'll do this in color here. So BC is 4 times x minus 1. So 16 minus 1, which is 15. And then CA is 5 times x, or 5 times 4, which is going to be 20. And then BA is 6 times x minus 4. So 24 minus 4, which is also 20. So you can see the isosceles triangle happening here where I've got 2 sides that are equal to each other, but not equilateral because that third side is 15. All right, moving on to the angle portion of this. So I say again, sometimes you might have to turn these to the side. This, anytime I've got these 2 tick marks right here like this, it's telling me I have an isosceles triangle. And if the 2 sides are equal, the 2 base angles have to also be equal. Okay, so these are equal, these have to be equal as well. And so if this guy's going to be x, that guy's going to be x too. And then I just need to do the sum of the triangle. Angles inside the triangle is 180. So if I add all this together, x plus 70, then 2x plus 70 is going to equal 180 degrees. And I subtract 70. I get 2x is equal to 110. Divide by 2. And x is going to be 55 degrees. So pretty easy. You just need to recognize that isosceles triangle. All right, number 19. A bunch of ways we can look at 19. What I saw first when I looked at this problem is these right here tell me that I've got two parallel lines. And if I've got two parallel lines cut by a transversal, right, I can look for that Z pattern, and I might have alternate interior angles, okay? So if I look at this right here, see this Z, then I know that this angle and this angle have to be the same. So this guy right here is going to be 70 degrees, right? And then I've got this inside triangle here to work with. So if I kind of consider this inside triangle, I know the sum of the angles in there should be 180. I know that 70 plus 45 plus x is going to be 180 degrees. And then I can combine 70 and 45 and get 115 or 115. And then solve for x. I can subtract 115 and I get x is equal to 65 degrees. Okay, so there's my x. So now I know that this is 65. And so now I have quite a few options for how I can find y. I can do another alternate interior with this transversal and say, okay, well, I see that Z pattern, so I know y is going to be 45 that way. Also, I've got a linear triple, so the three of these angles together make a line. And so if I wanted to find y, I could say, well, I know 70 plus 65 plus y equal 180. And 70 and 65 come together to make 135. I hope. Not. And if I subtract 135, then I can see y is equal to 45 degrees that way. Okay, so I can do it that way. But also I could have kind of recognized an alternate interior relationship right here with y and 45. So there's a lot of ways I could have worked this problem. And fourth period, did corresponding angles. So because you know this one's 45, you know this one's 45 because they're corresponding. And because you know this is 45, y has to be 45 because they're vertical. So there's lots of things that you could look at here. The same would happen with the 70. So 70 could bump up here to 70, and then 70 and 70 are corresponding there. So lots of things you can do. All right, moving on from 19, moving on to 20. 20 is a really more kind of straight traditional problem. You've got a triangle. it has 3 interior angles. I can combine them and set them equal to 180. So if I add all of this, right, so I would say 2x plus x minus 10 plus 55 has to be 180. And I want to be careful here and note that this is negative 10 plus 55. So this, and I'm also going to combine 2x plus x and get 3x. And there is a mistake on the key because my flu brain wasn't thinking clearly. And it's actually minus 45 on your key. So just ignore that. Subtract 45 here. You get 3x is equal to 135. Divide by 3, and x is 45. So this one's really kind of straightforward. I don't even need any color. Okay, moving on to 21. Lots and lots and lots of ways I can work this. I'm actually going to find, well, I'll do exterior angle theorem. I can find y, right? Y is exterior to this triangle right here. So I can actually find y just by adding 55 plus 60, which is some amount of degrees, 115 of them, I hope. So 115. Lots of ways I could have done that, but I know I can use exterior angle theorem, so I'm going to use that guy. And then once I know that's 115, then it's just a hop, skip, and a jump to get x, right? Because I know that x plus 40 plus 115 make a triangle, and so I can say x plus 40 plus 115 equals 180. So x plus 155 is equal to 180, and I subtract, and I get x is equal to 25 degrees. All right, so there's my x, and I should have boxed my y. Here's my y, and I'm done. All right, 22 is just like 18, so you got a 2x plus 30 equals 180 situation because it's isosceles. I'm just going to move on from that. And then 23 is just like 20, so I'm just going to add 90, 39, and x and set it equal to 180, and that will give me that one. 24 is just like 20 and 23, so I'm just going to add 30, x minus 8, and x, and set it equal to 180 and solve it. So I'm going to leave you to do that one. And I'm going to do 25. Again, I'm skipping some because I don't want this video to be insanely long. 75 has that exterior angle relationship. So the exterior angle is equal to the sum of the two interiors. And so I can just set these equal to each other and solve. So I'm going to set 4x plus 40 equal to the sum of these two. So 2x plus 3x would be 5x plus 20. So again, exterior equals interior equals interior plus interior. And now I'm just going to solve. So I'm going to subtract 4x over here and get 40 is equal to x plus 20. And then subtract 20 over here. And if you need the line to organize, no shame. So x is 20. Pretty easy once you recognize that it's just exterior angle theorem. All right, moving on. I'm going to kind of quickly go through this side, angle, stuff. So if you'll remember, if they share a side, that means it's congruent to itself. So we've got angle, side, angle, congruent to angle, side, angle. So yes, it's congruent, and we're going to use angle, side, angle to show it. All right, 27. We have They share a side, so this side's congruent to itself. And we have angle congruent to angle, but those are the only two pieces of information we have. And so really we don't have enough information to tell whether it's congruent or not congruent. So we're just going to say none because we have nothing to prove it with. Okay, 28. We share a side, so we have congruence there, and I'm going to use 2 marks because I already used 1. And so what I have is side and side that are congruent, side congruent to itself, and here's an angle congruent to an angle, and then I just check order, okay? So side, angle, side, congruent to side, angle, side. So yes, they're congruent, and I know that based on side, angle, side. All right, 29. 29, we've got our 2 triangles sharing a vertex. And so we've got vertical angles that are true here, and I should use 2 marks because I've already got 1. So I have an angle congruent to an angle. I have a side congruent to a side, and an angle congruent to an angle, and I just need to check my order and make sure it's the same on both. So I have side, I have angle, side, angle, congruent to angle, side, angle, in the same order. So I'm going to say yes, they're congruent, and I know that because of angle, side, angle. All right, moving to really 30 and 31 are the same. I'll use 30 since it doesn't have that weird little bite out of it. This is a tricky one. They share a vertex. So I've got angle congruent to angle. I have 3 marks, and I have 3 marks. I've got 2 marks, and I've got 2 marks, and I have to make sure they're in the same order. Sorry. So I'm going to go side, angle, side. Notice my 2, and then my angle, and then my 3. And then I try to do the same thing over here. And I have a hard time doing that. Okay, so I come over here and I say I'm going to go 3 to 2. So I have side, angle, side. Well, if I come here and start with 3, I have side, side, angle. So this one makes sense with its side, angle, side. But then I come down here and I've got side, side, angle. First of all, we know that if we flip that around, that spells the donkey theorem. So obviously this one's not going to work because of that, but also they're just not in the same order, and order really matters to us this unit. So this is going to be not enough information. We're not saying they're not congruent, we're simply saying we don't have enough information to tell if they are. All right, 32. 32, we've got the side shared with the side, so we've got a congruence there. I'm going to use 2 marks since one's already been used. I've got side, angle, side. I've got side, angle, side. So that makes sense. They are congruent by side, angle, side. And then last one of this section, we have 2 right triangles. So I'm automatically going to check hypotenuse leg. So we have a hypotenuse, which is across from the 90-degree angle. So a hypotenuse congruent to hypotenuse. And we've got a leg congruent to a leg. So we have congruence here because they're right angles, hypotenuses are equal, legs are equal. So it's true based on hypotenuse leg. All right, 2 more throwback problems. In a right triangle, if I knew 2 sides, can I find the third? Absolutely. So the legs are A and B. The hypotenuse is C. The legs are A and B. The hypotenuse is C. Remember, the hypotenuse is whatever is directly across from the right angle. So I can, if A squared plus B squared equals C squared for Pythagorean theorem, I can solve for x. So this would be x squared plus 9 squared equals 11 squared. So x squared plus 81 is equal to 121. I subtract 81 from 121. Let me not mess this up, and I get 40. So I know x squared is equal to 40, but I got to take the square root here so that I can get to just x and not x squared. And so remember, 6 squared is 36, and 7 squared is 49. So I know it's going to be somewhere between 6 and 7. Probably somewhere pretty close to the middle, actually, but maybe a little closer to 36 than to 49. And we end up with approximately 6.32. All right, one more. I'm going to label my A's, B's, and C's in here. So these are a little bit different because this one I solved for a leg, and on this one I'm going to solve for a hypotenuse. But if I set it up right with my A's, B's, and C's, then the algebra will take care of that. Right? So leg is A, leg is B. Directly across from the right angle is my hypotenuse, C. So I'm going to say A squared plus B squared is equal to C squared. Well, A is this crazy 4 times the square root of 3 squared. B is 4 squared. And that's going to give me C squared. So maybe the first thing I need to do is just type 4 times the square root of 3 into my calculator. So let's see, let me do that really quick. So that gives me like 6.9, and then I square that, and I get actually 48. And then I square 4, and I get 16. And that gives me 64. And this is, of course, a perfect square. So when I take the square root, I get 8. All right, guys, that is the end. I hope it is helpful. Have a wonderful night, and good luck.